Thank you, Natalie. And you'll notice I'm wearing my Kepler mission pin here today. Very, very carefully made sure I had the right jacket on. So on behalf of the Carnegie Institution, let me welcome you to our administration building here on 1530 P Street. It's affectionately known as P Street to all of us who are Carnegie folks. In 1900, Andrew Carnegie decided he got tired of making money. He decided to sell Carnegie steel to J.P. Morgan, which he did for $400 million, which was a lot of change in 1900. You can imagine that's equivalent to something like Warren Buffett's accumulation of wealth these days. And so he sold it to J.P. Morgan. Carnegie Steel then became U.S. Steel. And he spent the next 19 or so years of his life trying to give away his money. He's one of the first people that pioneered the idea of philanthropy. His quote was that a man who dies rich dies disgraced, so he did his best to try to give it away. I think by the time he died, he's given away maybe $1 left to the Carnegie Corporation of New York got. So they became the most richly endowed of all as many beneficiaries. But in 1902, he decided to build a university for the District of Columbia because he felt that the existing universities just weren't quite up to par, shall we say. Which I think the current universities will differ with considerably. But he got some advice from various folks, including the president of Hopkins. And in the end, he decided not to build another university, but to build something brand new, a research institution, where the scientists are hired to do nothing but research and not teach. And so in 1902, the Carnegie Institution of Washington was formed. It's still around today, thank goodness, through the very careful husbanding of the millions of dollars that Andrew gave us to start out. And to this day, there are 6 departments in existence. If you look on the wall right on the corner towards the breakfast room, you'll see a chart of the Carnegie Institution showing that through its history of a little over 100 years, there have been a total of about a dozen or so departments. Some of them did their job and were shut down. Other new departments were created. And just in 2002, when we had our 100th anniversary, we created a 6th department, the Department of Global Ecology, which basically worries about climate change. In addition, the other 5 departments are the Department of Plant Biology. Both of that and Global Ecology are on the Stanford campus. On the Hopkins campus, there's the Department of Embryology. Here in Washington, D.C., there are 2 departments, the Geophysical Laboratory and my department, the so-called Department of Terrestrial Magnetism, even though we haven't done magnetism really for, say, 100 years. We still kept the name. And we're both co-located out in northwest Chevy Chase, D.C. Then in addition, of course, there are the Carnegie Observatories out in Pasadena. They built Mount Wilson originally, where Hubble did his work. And they also built Palomar jointly with Caltech. But then in the 70s, they got tired of the increasingly bright southern sky, Southern California skies, and decided to go to Chile. So they began developing the Las Campanas Observatory in Chile in the early 70s, and in 1976 they opened up the first really big telescope there, the 2.5 meter DuPont telescope I actually use for astrometric planet searches myself. Even though I'm a theorist, as Natalie says, I have a night job running a planet search program, and I'm literally moonlighting because they only give me time, so-called bright time, when the moon is up, so that's a nice way of putting that together. Okay, but the real reason I'm here, yes. Sure, I'm sorry. Okay. So the real reason I'm here, though, is summarized by this title slide, which is that I also happen to be chair of something called the NASA Exoplanet Program Analysis, or ExoPAG. And so this is an activity that the whole point of me being here and telling you about it is that we are looking for regions where NExSS and ExoPAG can interact and help inform NASA's management headquarters what needs to be done in the area of exoplanet exploration. So let me start off by just defining what it is. I don't think Martin still is here, but yes, Martin is here, so he will notice some of his own words here in the next couple slides. I cribbed from some presentations by Martin. What is the ExoPAG? Martin should know since he's basically the program scientist at headquarters. So the ExoPAG is an open interdisciplinary forum, provides a way for information from the community to feed into NASA headquarters, eventually anoint as the chosen missions, are missions that are technologically feasible, and something that NASA can afford. And so you really want to put a fair amount of study into these things ahead of time. And the feeling was that let's try to identify the 4 best missions, so maybe 3, maybe 5. Paul said, we have a limited amount of money at headquarters all the time. You can imagine the pressures that people like Paul Hertz face. And the hope was just to have a few missions that could be studied in a fair amount of detail to make sure that when they are decadal Astro 2020 survey committee begins meeting, they have a short list of missions to put all the effort into deciding which one should be the top ranked one. So that was done in beginning January 2015, and my predecessor on the ExoPag, Scott Gowdy, pretty much led the charge on that and came up with the rankings that came from the ExoPag. And before we got started on that, though, the nice thing was that Paul Hertz had basically done his homework to find which were the 4 best missions to worry about. So he went through the last 2010 decadal survey, as well as something called the 2014 Visionary Roadmap for Astrophysics, and realized that if you take out the couple of missions for gravitational waves and gamma rays that will be probably done jointly with the European Space Agency, the 4 missions that were left that were high priority are Far Infrared Surveyor, a habitable exoplanet imaging mission, which really has exoplanets, obviously, as its primary goal, although we do other science as well. An optical UV IR surveyor, which usually goes by the acronym LUVOIR, because it's probably going to be pretty large. It'll probably be larger than James Webb Space Telescope, for example. So LUVOIR is its placeholder name. And then finally, an X-ray surveyor. So those were the 4 missions. And like I said, Paul basically had already solved the problem for us, but he went ahead and threw it out to the 3 PAGs and let them decide what to do about it. And Scott Gowdy put together the consensus from the ExoPag point of view and basically said, yeah, those 4 are the ones that we should be focusing our efforts on for Astro 2020. And in addition, pointed out a few other comments that, well, we know that WFIRST has been anointed for launch something like 2024 or 2025, and it's already had basically a chronograph added in as a perhaps fragile but part of the baseline for the mission. And people have been talking about star shapes, as I mentioned before, about a separately sort of an external chronograph, as it were, where you fly a separate spacecraft with a cleverly designed star shape to block out the planet's light, the star's light, so you can see the planet's light. So there's a feeling that there's a need for a few things besides these 4 major missions to be studied. And in fact, a star shade might be able to be flown as a so-called probe class mission, something less than 1 billion. And so the feeling from the ExoPag was right away that, hey, besides these 4 for the big guys, the large class, Astro decadal surveys break things up into large, medium, and small. And so there should also be perhaps a medium-sized mission, a probe class mission that could be considered. And ExoPag threw out a couple ideas for what that mission might be. So that was presented to the Astrophysics Subcommittee, and the key point was this one here. That's really what Paul Hertz was looking for. And all 3 PAGs agreed on that one. So that was we were in violent agreement on that approval of Paul's basic homework problem solution. But as you saw from the previous one, we also raised the idea of having probe class missions. And so in January of this year, Paul again came back to the 3 PAGs and said, listen, what should we do about getting ready for probe class missions? He didn't want to spend quite as much money on thinking about probe class mission concepts as he's doing for the large missions. But he said, we should do something to make sure that there's a level playing field for various concepts that might be presented. And so he offered us 2 options. One is to go ahead and put a ROSA solicitation to choose maybe 10 or so competitors funded at a rather modest level, maybe only 100K or so, to do a 1-year study and see what they could do in terms of really fleshing out the concepts in terms of technological development and costing, as well as the scientific merit. Or we could just do nothing and let the community, senators and active groups put together little white papers and submit them to the decadal survey, which is sort of what was done to some extent back for Astro 2020. I happen to be on the electromagnetic observations from space subcommittee on Astro 2010, and I think we had 50 or so white papers submitted, which requested a total of roughly $40 billion worth of space missions. And at that time, we thought we had maybe $4 billion to spend. So 10% success rate, that's kind of like what RNA programs are these days too, so we can't complain too much. But I'm sure for Astro 2020, will be, besides perhaps these funded studies, there will be a number of sort of home-brewed white papers as well, because all input is welcome for the Astro 2020 Decadal Survey, I'm sure. So we again went through our due diligence and had a couple of meetings and lots of telephone conferences to talk about this, and feeling was Exopag fully supports the idea to have this pro-class mission, as you could tell, since we were asking for it back when we were doing the large mission charge. And needless to say, we also thought the first option should be preferred. There really should be a little bit of money at least out there to do this, so that and to have all 10. Don't take the sort of $1 million you're talking about and divide it up into 333K efforts. Have 10 concepts, because you really need, this is for the entire astrophysics division. So it's exoplanets, cosmic origins, and physics of the cosmos. You really need at least 10 of those to try to cover the entire suite of scientific interests. So the idea of having 10 concepts made perfect sense to us. We realized that they should try to do as much as they can of the groundwork to make these proposals really reasonable to be presented to decadal surveys. And in particular, this would allow folks to compete for that 100K or so. Folks who are not at centers, who may not have institutional backing from a NASA center, they could then perhaps at least have some funds to do a serious study. And in fact, our main concern that we raised was that, well, 100K really doesn't go very far if you're going to have put together a white paper about a $1 billion class mission or so. That still is, there's a lot of effort that goes into writing one of those papers. I should say that the other two PAGs agreed with that. They also fully supported the probe charge. So that's going forward, I believe. So given that, as I said, this focus on future missions, one of the other activities that the Exopag has been involved in for the first time this year is trying to prepare the annual technology gap list, which is a list which is used to inform the spending by NASA headquarters on developing different technologies that might be used for some missions all the way out into the 2030s. There are charts that talk about missions that would not launch until 2035. They're planning for right now. That's the sort of forward-thinking NASA has to do. In the past, the two other PAGs, the Cosmic Origins and Physics of the Cosmos, would go ahead and involve their PAGs in this process. That was not being done for exoplanets for some reason. But feeling was from the Astrophysics Subcommittee that Exopag should be more directly involved in this. So we put together a process where a cycle will go through every year. We have a winter Exopag meeting where folks from presumably JPL, Nick Sigler is the chief technologist for Exoplanet program. He and Ron Morgan, as his aide, will be presenting a draft technology gap list for us to be considered. He'll ask for input from folks from the community all the way along, revise things. And in our summer meeting, which is going to be coming up in San Diego in a couple of weeks, we'll see what the revised list is and see if there are any final changes that may be made. That will then be submitted to the relevant NASA program office, and then we'll repeat the cycle each year. So that way we'll try to make sure that we have a lot of input from the community in developing this list. In the past, of course, there has been community input involved in developing TGL. It was done in a more informal basis rather than this more formal open call to the community. So that's one of the major activities underway for mission support. And of course, there also are these study analysis groups. So we have a number of these reports already done. There are 7 that have finished work, and you can find all you would like to know about them if you look on the Exoplanet Exploration Program webpage. 4 of them are actively working right now. There's one new one that's just been proposed and accepted by Astrophysics Subcommittee, and there are 3 new ones being developed right now, which are summarized here rather quickly. There's one that David Ciardi and Joshua Pepper are talking about to try to speed up the process of being able to do planet confirmations with TESS. In terms of the Kepler mission, we had lots of planetary candidates. We still have a lot of planetary candidates, but it's unclear which ones are true candidates, or true planets, which ones are false detections. And so there's a lot of work that can be done on the ground to follow up the space-based detections to see if they really are confirmations. And the hope was to get a start on trying to do that for TESS, as well as for the ongoing K2 planet detections. Also, a possible, or most likely is going to happen because in terms of the technology development efforts that I lead with my other hat on, we really want to know what the best ways to define technical terms like raw contrast, ideal contrast, post-processing contrast, so that when we compare different concepts for star shades, we can really compare apples to apples and make sure that when you're saying this star shade will do this well, this star shade will do that well, can you really make sure that you're really talking about the exact same quantity. So Tiffany Glassman will be chairing that one. She's in the process of putting that together, and we'll be seeking approval for that at the Exofag meeting in San Diego, as well as from the Astrophysics Subcommittee meeting in July. Another one for the same sort of metrics. You might think that the chronograph people know exactly what they're talking about when they're talking about raw contrast and suppression, but there are still, if you have 10 different people, you have 10 different definitions for how to do it. This group will try to put together a definition for how a chronograph contrast and starlight suppression should be defined. So those hopefully will be accepted, approved and accepted soon. So here are the existing SAGs that are still working. SAG 12 is one that Eduardo Bendick from NASA Ames has been running for some time. This is the idea of trying to do astrometry with WFIRST. Astrometry, to remind you, is the looking for planets by watching the star host wobble back and forth in the sky. It's sort of the most ancient planet detection method, but it's the one that's never actually found a planet so far, which is a little bit distressing, especially since I've got my own ground-based astrometric planet search program. I'm definitely working uphill on that one. Eduardo has not been able to make a lot of progress with this one. In fact, he's trying right now to increase SAG activities by getting more folks interested. So if any of you are closet astrometrists, please send Eduardo Bendick an email and ask him if you can join in and help out. SAG 13 is by Russ Dolokhov from NASA Ames. This one has become incredibly important these days because one of the things we really want to know is, given the Kepler detections, as well as what's been done by direct imaging and especially mostly all by radial velocity for the shorter period orbits, what is our best extrapolation to the actual underlying demographics of planets of all different sizes at different distances from FGKM stars. And so Russ Dolokhov has taken it upon himself to try to get a group of folks together to actually agree, first of all, on just like how do we bin the data. Believe it or not, well, we're going to say we're talking about radii of 1/4 of an Earth radii to 1 Earth radii and 1 Earth radii to 1.25 Earth radii. This was a battle for several months. Well, no, it should be 0.9 Earth radii to 1.1 Earth radii. This is sort of things hurdles they had to jump over, but they successfully did that. So they've agreed on the standard eta bins. This is a major triumph of herding feral cats. And they now invited folks to do their own method of interpolating from or extrapolating from the Kepler data to figure out what actually fits in each bin. And they have so far, I think, 11 participants have submitted input. Hopefully, the 12th one will be Wes Traub, who had submitted a paper I think 1 or 2 weeks ago with his own estimates of the etas, including the most important one of all, etas of Earth, habitable Earths around G-type stars. And so once Wes puts his information in, I'll crank up that 11 till 12. So I'm not going to steal any of Russ's thunder here by showing the numbers, but needless to say, these eta bins are pretty high because Kepler, of course, has shown that planets are quite, they are the rule, not the exception. Okay, SAG 14 is one which sort of gone through a rapid brightening and it's starting to fade right now. There's hope to do something better to prepare for the launch of TESS. Kevin Stassen and his folks were trying to see if they could come up with a way of doing some pre-selection of the best target stars for TESS to look at, even though, especially since TESS is an all-sky survey, you can imagine your target list is immense. But something like half of the stars that they look at, they know ahead of time, we're probably going to have a lot of our stellar variability, which will make it very hard to measure the radial velocity jitter, because an important part of TESS is to not only discover them by transiting, but have them be massive enough or short period enough that you can also do a follow-up radial velocity measurement to get the mass. Of course, once you have you of course take care of the sin I problem, because if you've got transiting planets, you know the angular orientation, and so that way you actually get directly the mass as well as the density and everything else you want to know. So the hope was to improve the TESS target list by doing a rather high cadence observations of a lot of the possible stars, at least perhaps the North Galactic Pole that TESS, due to its sort of a strange orbit, has the most observations of. But turns out that the amount of money that would be required and the time scale involved is probably not going to allow that to happen. And so this SAG is a little bit dormant right now. They're trying to figure out what else they can do to get ready for TESS to perhaps improve its yield. Okay, another one by Daniel Apai here, number 15. This is also fairly new. It's basically saying, well, you're about to see 16 about biosignatures, but there's a lot of other interesting things you want to know about exoplanets as well. And so Daniel very rightfully pointed out that there's lots more besides simply biosignatures. What can be done? What sorts of ideas should be, science questions in particular, should be laid out for future space missions? And of course, a lot of this is being driven by this planning for the Astro 2020 decadal survey. And so this SAG, as well as the one I'll show you next on biosignatures, they're not only thinking about what can be done to help out with WFIRST, which will be launching in 2024, 2025, but also having input for the large mission studies that are already underway for HAVEX and LUVOIR in particular that are most relevant for exoplanets. So Daniel's been having monthly meetings on this. They've done a lot of work on laying out the high-level science questions, and they're working hard on that. Again, I'm sure this is something that if you haven't heard about it from Daniel already, you're welcome to join his effort. Now, here's the newest one of all, biosignatures with Sean, Domino Goldman, Nancy Kang, and Nikki Parenteau. I could let Sean talk about this too, but it's quite simple. Go back to think about what are the biosignatures people have talked about, the molecular species in particular that could be found in exoplanet atmospheres, making sure that they are you have an argument for, once you know their abundances, for arguing that they were formed by biotic processes rather than abiotic processes. Which wavelengths are we looking at? What signal noise do you need to see them? What resolution, what resolving power? And the big thing is there's going to be this 3-day workshop, which again you guys probably know about already, at the end of July, where the Nexus will be taking lead on this along with NAI and this new SAG to write a report that will be ready by roughly a year from now. Okay, so those are the SAGs, and let me just conclude by saying that here's what the ExoPag does. We have these monthly telecons. The active SAGs are going to be continuing their work. We're going to try to get these new ones on the chronograph metrics and the starshade metrics and preparing for test accepted this summer so they can get their work done ahead of time and be relevant for the missions they wish to support. We have a meeting that will be held in San Diego, which is an open community meeting. You're all welcome to attend. If you want to spend a couple more days in San Diego, please come visit us. And then we'll also be having a meeting before the AAS winter meeting next January in Grapevine, Texas. And if that doesn't ring a bell with you, it's close to Dallas-Fort Worth Airport, which is the key metric for that one. So it sort of makes sense. You know, wow, I guess we could have met in there must be an airport hotel, but I get that would have been a little bit too much, a little bit too depressing to meet there. So the Grapevine, I'm sure it's actually another one of these Gaylord hotels, like the Kissimmee meeting was held at, or like the National Harbor meeting. So it's one of these spectacular. I think they actually used the same floor plan as for the Kissimmee hotel. I think the Grapevine hotel is exactly the same thing. It has the same restaurants, the same layout. So I couldn't find my room at Kissimmee, but I think at least I'll be able to find my room in the Grapevine. So okay, so. The key thing, the final takeaway is that Nexus, we want to absorb your input to help us inform what the exoplanet community is thinking about. And at that point, I'll ask if you have any questions. Ah, Martin. He's going to correct all my misstatements now, right?
So hi everybody. Alan is doing a bang-up job. Many of the analysis groups that you see there are fairly new, and you know there are a couple of things to point out. One is that many of those new SAGs are being run and helped along by you guys here as part of Nexus. I think it's one of the success stories of Nexus so far is that they plugged themselves into the ExoPag really efficiently and really well. And it's really obvious that you guys are doing some hard work towards these goals. The PAGs are slightly different to Nexus because they're a little more plugged in to NASA's strategic goals, to the missions and to the concept studies. So it's a bit of a two-way door. You know, sometimes NASA says it would really like to see some analysis, and is it possible for you guys to do it? And sometimes the PAG community says, you know, NASA might be going in the wrong way, or it's doing something not quite right. Here's some analysis to prove it. Whereas you guys are more sort of freeform, and you kind of have the freedom to go anywhere you like. And I really like the combination of the work that's going on inside the PAG and the work that's going on inside NExSS, they really complement each other brilliantly. So I can only repeat what Alan says. These meetings occur twice a year. They're a day and a half before each AAS. And I think the more of you guys that go, the more healthy the exopag will be, and the more healthy exopag will be as well. So you're very welcome. The other thing to add is that this is just one PAG. There are three. There's one for the structure of the cosmos, and there's one for cosmic origins. And so you guys work, or some of you work on the specific problem of planet formation. And it kind of sits in a very gray area between the exopag and cosmic origins. So while you've heard a great talk on the exopag, also take a look at what's going on in the copag, which is like the cosmic origins sister of this, where maybe planet formation is getting shortchanged because it's sitting somewhere between the two organizations. And if you guys plug yourselves in there, maybe you can do a lot of good.
That comment seems especially relevant to the far IR surveyor planning. Yeah. Any other questions for Alan?
Yeah, in fact, the far IR surveyor folks are actually realizing that they should be more relevant to exoplanets, and so they are recently have proposed perhaps shortening their minimum wavelength from 25 or 30 microns down to 10 microns to try to get into things of interest for exoplanet atmospheres. And so they will be presenting their case at the San Diego meeting as well. So we will hear from ABEX and LUVOIR, but also from Far Infrared Survey. We haven't quite decided to invite the X-ray surveyor folks, but maybe we're remiss there. But if you can think about, there's some work for tying high energy particles wavelengths to exoplanets around host stars, but right now at least the X-ray surveyor folks don't seem to be interested in pushing the exoplanet edge of their parameter space.
And thank you for those comments, Martin. I know, there are many opportunities to participate in these committees, and it often feels like a thankless job, I'm sure, for many, because it is voluntary, so I appreciate that. Yesterday, Ellen Stoffen, maybe she was giving a nod to the interdisciplinarity of NExSS, but she tied it to the PAGs, and she kind of wondered out loud if we needed to restructure the PAGs to take into consideration the need for multidisciplinary research to accomplish some of our goals. I was thinking specifically of like exobiology, for example, earth science, even planetary science. And I'm wondering if you have felt that need, Alan.
Well, this is in terms of like the executive committee?
Yeah, just PAG operations in general.
Given that the exopag EC is not too terribly large, I guess Martin is roughly maybe 10 or so folks, and we're kind of pushed to make sure we have the technologically oriented people in. We have a few folks who do, say, protoplanetary disks, and a few folks who do radial velocities, and a few folks who do atmospheres. It's a little bit harder to have someone who does, say, terrestrial plate tectonics, even though it might be of interest for habitability. So it's not a question of disinterest, it's just a question of having a small enough executive committee that you can actually get things done on a given telecom. But certainly all the communities that we're talking about, heliophysics, earth science, planetary science, astrophysics, are all welcome to attend these meetings. They are truly open to everyone who pays the AAS registration fee anyway. That's the only ticket to get in the door.
Yeah, apparently it is, huh? Very good. Any other questions for Alan? Thank you so much.
Thank you.